Okay, so we've been talking about conics, and we can take a typical conic, maybe a upward facing parabola, and we're able to shift it around horizontally and vertically. We can write equations for it. We can look at the equations and determine what has happened to how our conic section has shifted, so on and so forth. But now, if we look at the more general equation for a conic, a more general, not necessarily the most general, but a more general, that takes on this sort of form. So it has all the terms that we had before, but now we've added this coupling term where x and y are multiplied by each other. This will result in a conic that potentially rotates. So instead of just sliding in the horizontal and vertical direction, we might get that. We might get that also occurring, say with our parabola, but in addition to that, we can have a rotation. Now our parabola might face this direction, like this. Everything else would be the same, but it's rotated. Notice the vertex has a horizontal and a vertical. Excuse me, still, because this equation still has most of these other terms. So, let's talk about how to recognize what type of conic section we have from our general equation. So if we just decide not to talk about the degenerates, like a straight line or a point, in this case A and C are not equal to 0. Then we can come up with a relationship when b is not equal to 0. If we look at this relationship, b squared minus 4ac, and it could be one of three things. It could be either equal to 0, or it could be less than 0, or it could be greater than 0, depending on whether a times c times 4 is greater than b. This is also the relationship, the argument under the square root in the quadratic formula, you recall. So in cases where in our most general relationship, when b is not equal to 0, we have somewhat of a complicated, it's not really complicated, but we have b squared minus 4ac as an indicator, and we can use this to determine if it is equal to 0. This is going to end up being a parabola that is probably rotated. This will be an ellipse. Or a circle. And this will be a hyperbola. Now, if we don't have this coupling term, in other words, if b is equal to 0, then you can see this relationship reduces to just A times C equals 0, and A times C is less than 0. Oops. Not less than, actually A times C is greater than 0, because it'll be a negative. And when we divide -1, that'll flip the sign, and A times C is less than 0 for our hyperbola. So you might get confused like I just did when I was writing this down, but when you think about it, you understand. So for an example, we'll have, let's look at a general equation. Say we have 8x to the 4th minus 12xy plus 17y squared minus 4 square root of 5x. That's good enough. Equals 0. So the terms might not be in the proper order. You might have to do some a little bit of algebra to set things up like this, so you can pull out an A is equal to 8. Here B equals minus 12, and C equals 17. So if I'm going to look at my relationship b squared minus 4ac, what does it equal? Or how does it relate to 0? So I have minus 12 squared minus 4 times 8 times 17. And this equals minus 400. And minus 400 is less than 0. So what we're looking at here is an ellipse. Let's do one more. Suppose we have y squared minus 4x squared minus 4y minus 8x minus 4 equals 0. Let's go with y squared here. Well, we have to set it up in this form. ax plus bxy plus cy squared. So the x is actually the a term. So a equals minus 4 here. B equals 1. And c, of course, equals 0. So or actually b equals 0. My mistake. B equals 0 and c equals 1. We can use either equation. And it might be best just to concentrate on this equation, so you don't confuse yourself with the signs over here. So I have b squared minus 4ac equals what? And so I have 0 minus 4 times a is minus 4 and c is 1. And we can see that that equals a positive 16. And positive, if it's greater than 0, we have here a hyperbola. And we could figure that out by completing the square. So this is a shortcut really to completing the square. So we could group our terms. We could say y squared minus 4y. And then we'd have minus 4x squared minus 8x. And all this equals positive 4. Brought the 4 over the other side. And I could start solving the, I can complete the square here. We've got y minus 2 squared. So on and so forth. Well, I can complete this. So take out a minus 4 x squared plus 2 here. This equals 4, but since I have added 4 over here, I have to subtract 4 here. And it looks like I'm running out of time, so I'm not going to finish this. But you can finish the rest of this. Complete the square. Well, actually, I'm almost done. Y minus 2 squared minus 4, and then this is x. Half of that is 1 squared, x plus 1 squared. And this is 0 over here, but I have 1 that I add times 4. So this is going to be 4. And it looks like a minus 4 even. So after I multiplied it by minus 4, so I end up with x plus 1 squared minus y minus 2 squared over 4 equals 1. When I divide through by negative 1. Hopefully I didn't make a mistake in that. I'll check it and edit it if I have to.